my name is Benjamin, and welcome back to my channel, Learn a Lot. If you have not subscribed, yes, this is the time to do it. Subscribe and hit like, comment, and share. So today I'm gonna take you on a little bit of adventure. So we're gonna use R again to do change detection. So we're gonna use about 32 images to try and see how features change over time. So we're gonna classify the image in three classes: base, soil, vegetation, and water. And then we're going to compare the features over the 32 images, which are 32 points in time between 2018 to 2020, and see how those features change over time. But now, today's lesson, we call it change detection in numerical opinion. So we're going to do all our analysis numerically, not using actual maps. So we're just going to extract all our pixel values and try and analyze it like we talked about in the previous video. And if you haven't watched those previous videos, you can actually follow the link that is appearing on your screen right now. You can watch my previous video. And so let's go now. So if we remember, in my previous video, I showed you how you can actually load data into R, and we created two main files. Sorry, let me close all these things that we do not need. The function file and the main the image manipulation file, which is the one we're looking at right now. And we've got the function file. Last time we created an NDVI file, which we're going to use this time around. So I showed you how to load those images and the shapefile. The fourth line is the one that you're not familiar with, but this is how you load data from a text delimited file. So we're loading climate data, which we're going to use later on. So stick with me, and we're going to do this. So we're going to start first by calling the source file, which is going to load the function R file, and it's going to load the images and everything that we need, the NDVI function that we already created in the previous tutorial. So now, before we move on with our tutorial, this is what I would want us to do now. We need to type a new function. That is a function that we're going to use that will help us to extract the pixel values and stack them together in a table so that we're able to manipulate our information and do the bar plots that we want to do in this tutorial. Remember, when we're doing numerical opinions, we're talking statistics. Come on, guys. So I'm gonna call this function, I'm gonna call it area, or let me say surface area. So that's like Saria. I don't know if that's anybody's daughter's name, but if there is any such girl that is named Saria, I want to marry her. So function, we're going to write that function, and we're just going to accept one variable. So in this, the variable that we're going to accept is a variable that contains all the pixel values that we acquire from our set from the NDVI image that we'll produce from this function. So whatever output we get from this function, we're going to extract their pixel value and then do the change detection analysis. So we want to just limit ourselves to three features. The first one will be water. We're going to initialize it. The second one, we said it was going to be base soil. We initialize it to 0. And then the third one, we said it was going to be what? I think it's vegetation. Then we're going to initialize it to 0 as well. Right? So now we're going to write a function to loop through the data set. So we're going to say I, for I in 1 through to the length of x, yeah, open, that's, so we're gonna say, we're gonna count the number of pixels, because that's what we want to count. We want to see the surface area that water occupies in a specific year on the image. So we're going to count it every time the feature is equal to 1 to water, then we count it to 1. But before we do that, we need to specify first what are the pixel values sorry, what when you compute NDVI, what are the pixel values that characterizes water? In the previous tutorial, we saw that every pixel value that is below 0 characterizes water. So we're gonna say every pixel value that is less or equal to 0, we're gonna give that a watermark. That's water for us. Else, if I'm gonna go ahead and say if the pixel value is, let's say it's greater, what am I doing? It's greater than 0 and sorry, that's the problem when you want to do dark modes. Or that same pixel value is less or equal to, I'm gonna go ahead and cut it at 4. Or let me say 3. I'm gonna go and cut it at 3 and say, so if it's less or equal to 3, then we're gonna say that is base soil. That is base soil. Sorry, base soil. So we're gonna say base soil plus 1, and then else everything else is just vegetation. Remember, this is just by default. It does not necessarily mean that the classes, as we demark them, are the only features that are there. We just doing a general thing to just show you the concept. But when you're doing like a proper image classification, then you can have all those different classes, and then you can do nice things. I mean, the next tutorial that we'll do, I think I'm gonna do an image classification. We're gonna do one in what you call this, it's going to be an object-based classification, and then we're going to compare that with an image classification that you do in R using neural networks, and then we're going to compare the accuracies. Then we can use those values to actually compare the different classes that we can find in a certain image. But for now, we're just going to limit ourselves to these 3 classes. So now, once you've got all these values, you need to go get out of the for loop. Then you create your table. So we're gonna call a variable that we're gonna name surface, and then we're gonna say surface. We're gonna make it, let's say, I'm just gonna make it as yeah, let's just call it as data frame. Let's give it a frame, sorry, a frame. Let's call it data frame, and then we're gonna see bind. Remember, we've got 3 variables here. We've got water, we've got base soil, and then we've got vegetation. So now, let me explain to you a bit what this code is doing. Something's wrong. My changing is not behaving. There's something that went wrong somewhere. Okay, what happened there? Oh, sorry, that is the issue. No wonder my code is not highlighting here. So, did I correct it properly? Yes. I need an if here. Else if. Yeah. No wonder this was not colored. But you see, that's the point of me including all these errors here, so that you know and see how I'm correcting them and you'll be able to do it. But I was saying that as data frame, a data frame is like a table structure where you have columns and rows. So in my table structure, I want to have 3 columns. One will be water values, base soil values, and vegetation values. These values, I'm getting them from these if statements. So these values will hold the number of pixels in each image that covers water, those that covers base soil, and those that covers vegetation. And then we're gonna return these data frame. That's the one we're interested in. We're gonna return this data frame that we've called surface, right? So let me save that so that I do not lose out my thinking. So now our function is complete. Now that our function is complete, we're going to move on to this file, the image file, where we're going to start loading our image. Remember the last time we used only, I think we used only 3 different images, but in this case we're using 32 images, and that's a lot of data. In those 3 images in the previous tutorial, what we did was we wrote a single code, a single line code where we combine the rasters at the same time as we're converting them from lists to raster. But this time around, we're going to have to go through all the images one by one and convert it to raster, then combine them as a stack. So if we do those steps separately, we're going to have a long line of code, which is going to take us a lot of time typing. But instead of doing that, we're going to use for loops to loop through all our images and then convert them to raster and then stack them together. Remember, when we load the images like I showed you here in the function file, you load them as list files, so they are not going to be used as rasters if they are in this format. So you need to convert them to raster, but when you do that, you do that one image at a time. That's why we need a for loop, so that we do that every single time that we're loading a certain image. So this is it for this tutorial. Thanks for watching. Let's meet in the next tutorial where we will see and discuss how we can use bar plots to monitor change of the different features over time and see which feature has increased in space and which one has decreased in space. So until we meet again, take care. See you in the next tutorial, part 2 of change detection numerical point of view. Cheers.